All I've got is two linear programming problems that I want to work, and I want to go through these with a fine-tooth comb and explain them very, very, very thoroughly. All right, so this problem says a manufacturer of lightweight mountain tents makes a standard model and an expedition model. Each standard tent requires yada, yada, yada. Each expedition requires yada, yada, yada. The maximum stuff available, so on and so on. So I'm just spot reading. All I'm trying to do this first time through is just get an idea that I've got two types of tents, and it looks like there's a cutting and an assembly portion of this. And I've got only so many hours for the cutting, and I've got only so many hours for the assembly. Then it comes down and says we make a profit of $50 on a standard tent and $80 on an expedition tent. How many tents of each type should be manufactured each day to maximize the total daily profit? Now, the first thing I want to do here is I want to set up my variables. So I'm going to let X be the number of standard model tents. And I'm going to let Y be the number of expedition tents. I don't know the difference, but tents are cool. I love camping out. Okay. Now, the next thing I'm going to do is I'm going to start the LP process. Now, how can you tell a linear programming problem from a system of linear equation? Let me see if I can get this to be clear. Yeah, I think that's actually a little bit clear. How can I tell the difference between a linear programming problem and a system of linear equation problems? Because those things look a lot alike. Well, the difference is when you see the word maximize and minimize, well, maximize or minimize, you know you have a linear programming problem. And the linear programming problem process is the first thing you want to do. You know, and I've covered this in previous videos, but we're going to get into it a little bit more in depth here, is you want to state your objective function. Now, your objective function is something like a z or a p. It can vary, and you're going to maximize or minimize some statement. Now, sometimes you'll see this written otherwise. You might have maximize or minimize some z equal to some statement. But nevertheless, what you've got is you've got the keywords, whether you're maximizing or minimizing, and you've called it either usually a z or a p, and then you've stated your objective function. All right? Second thing we'll want to do is we'll want to set up our constraints. The third thing we'll want to do is we'll want to find our feasible region. And the fourth thing we'll do is we'll find our solution. Now, these four steps are a little bit more involved than I just made them seem to be. All right, gang, let me grab a sheet of paper here and go over some of this stuff. I'm going to keep the... All right, so the first thing I want to do here is I want to talk about this objective function. So objective function is something you can always get from what you're trying to maximize or minimize. So I know I'm going to maximize my objective function. I'm going to call that z, and I'm going to maximize the profit. Well, I see right now that the company makes a profit of $50. I'm going to circle things as I go through. It makes a profit of $50 on the standard tent So if I let x be the number of standard tenths that I produce, then 50 times x is going to be the profit on the standard tenths. I make 80, well, I don't make anything, but the company makes $80 for each standard model tent. I'm sorry, for each expedition tent. So this right here is my objective function. That's what I'm trying to maximize, subject to certain constraints. Now, the next thing I do is I come in and I write subject to. And this is where I come in and make my mathematical statements that are presented in the problem. Well, what I notice when I read this standard tent, I see that there's a cutting component and there's an assembly component. The expedition has a cutting and an assembly. And then I come on down and I see that the maximum available hours per day for the cutting is 32 hours. So I know that the cutting from the standard tent plus the cutting for the expedition tent can't exceed the total amount of cutting. So I'm going to circle those things. So I've got 1 labor hour for the standard tent. So this one right here pertains to cutting. I know I've got 2 hours cutting on the expedition, but that amount can't exceed the total of 32 hours. All right, so apples plus apples is apples, oranges plus oranges, same thing we talked about back in systems of linear equations. That sort of stuff still holds true. Now, I've got my 3 up here, 3 labors from assembly. And then I've got my 4 labor hours of assembly for the expedition. And that can't exceed the 84 hours. So that inequality pertains to the assembly part. Now, guys, I'm dealing with real life stuff here, tents and people and hours they work and so on and so forth. But X is the number, as we saw back over here. Keep the eye on the prize here. X is the number of standard tents and Y is the number of expedition tents. So for common sense reasons, I know that both of these values have to be bigger than 0. Well, 0 or bigger. I can't produce negative expedition tents or negative standard tents. All right? So what I've done now is I have created, this part right here is called my constraints. So I've created my constraints. I've created my objective function. And now it's time to create my feasible region, because the fundamental theorem of linear programming tells us that the maximum or minimum value has to happen at a corner point of a feasible region. So what I need to do here, first and foremost, is I need to turn these things into y equal. But something that's going to help me along the way, before I get started into that, is create what I call my x-intercepts and my y-intercepts. And I'm going to do this for the first inequality and do this for the second inequality. Now this is going to give me a lot of information, and it's going to help me out here in just in another situation too. So creating the x and y intercepts has a twofold advantage. To help us graph, to set up the viewing window on our graphing calculator, and determine the ordered pairs of our feasible region. So this is twofold advantage. Now the easiest way to get your x-intercept The x-intercept, what's the definition of this? It's the x value and y is 0. It's where our line crosses the x-axis. So for obvious reasons, or maybe not so obvious, so I'll point it out. For obvious reasons, let me come down here in the corner someplace. If I have an axis, x and y, and I have a line that crosses through there, the x-intercept is that value right there. Notice its y value is 0. The y-intercept is there. Notice its x value is 0. So I don't know what this point is, but I know it's 0 something. And I don't know what this point is, but I know it's something comma 0. So the value of y is 0 for the x-intercept. The value of x is 0 for the y-intercept. Well, I can use that to my advantage, creating the x and y-intercept. So for this very first one, this one right here, x plus 2y less than or equal to 32. To find the x-intercept, all I need to do is cover up the y. Because I want a 0 there. 2 times 0 just makes that go away. So what do I have? X is 32. For the same inequality, how do I find the y-intercept? We'll cover up the x. Now mentally, can we solve 2y equal 32? Yeah, divide both sides by 2. We know the y-intercept is 16. Let's do the same thing for the next one. The x-intercept, cover up the y. Well, what's 84 divided by 3? You're like, well, I can't do that. It's no big deal. It's 28. For the y-intercept, cover up the x. Divide both sides by 4. What's 84 divided by 4? I can see that's 21. Let's say you can't. It's not a big deal. Don't worry about it. I'm sure you were given talents I don't have. Okay? 21. Now, what I now know is that my x-intercept is going to range somewhere between 28 and 32. So when I set up my viewing rectangle on my calculator, I need to have my viewing rectangle somewhere around 32. I want my picture to go out far enough for me to see everything. My y-intercept, I need to go up somewhere around 21. All right, so the next thing I'm going to do is I'm going to solve these two, put those in y-intercept form. So the first thing I would do is I would have 2y less than or equal to negative x plus 32. Divide through by 2. Saw something on Facebook today I found was kind of interesting. 4 mistakes people make in learning mathematics. And one of the biggest mistakes that they reported, and I agree with them completely, students get messy when they're working problems. All right, let's take this one down here. So I start out with 3x plus 4y. I know I'm going to take the 3x across. Now, some students will get confused here, and they'll see that they create a negative, and they'll say, no, there's something going on when we create a negative sign that we have to change the inequality. The only time you change the inequality is if you multiply or divide by a negative number. All we did is we subtracted 3x from both sides. So that doesn't apply. That doesn't affect the sign of the inequality. Guys, I'm going to divide through by 4 on every single term. So obviously on the left-hand side, I get y less than or equal to negative 3/4. X plus 21. Some of this we already knew, didn't we? That 21, well, we knew that's what we had there. This y-intercept is 16, we knew that. But the x-intercept, you've got to do a little bit more work, and it's easiest to do it in this form when you have this situation. Okay? And don't forget, we still have the obvious constraint that our number of expedition tenths and our number of standard tenths has to be greater than or equal to 0. Well, gang, what I would do now, I'm going to use this calculator here because I think I've used it less, and I want to set this up for you. Trying to get this where you guys can see everything. That works pretty cool. All right, cool. So, guys, first thing, to make sure I don't get any craziness, I'm going to go up and go second function stat plot, hit number 4, hit off, and done. So I've turned all my stat plots off because sometimes if those are turned on, they can create issues. I had one semester where I had 2 roommates, and one was taking my 1500 level class and one was taking my 1700 level class. Well, my 1500 level student would turn the stat plot on every single time she came to class. Well, that always messed up with my other student who was taking 1700, who was trying to do finite math. So anyway, so guys, let's go to y equal. Let's just clear out a bunch of stuff. We don't want all that stuff anymore. Okay? So I'm going to put in the negative 1/2, and I see that that's negative 0.5x. It's going to be easier for me to put in decimals, but I'll tell you what, let's say that we didn't see that. If you didn't see that, what you'd want to do is you would want to put all of the fraction in parentheses and then do the x. Okay? That's going to be one of those places where I'm going to know who has and hasn't watched the videos, because this is going to be something I'm going to point out a lot. The negative 3/4, put everything in the parentheses except for the variable. And of course here we have plus 21. Now if we just hit graph, we're not going to accomplish our problem or accomplish our goal of solving the problem. So next thing I have to do, I need to turn this into inequalities, as I've talked about previously. We're looking at less than, so that's when the arrow points down. Now there's a good chance now if I hit graph, I'm not going to get anything worthwhile, because I got to come up here and hit window and make my window look appropriate for this problem. So I know that my x-intercepts run from 32 to 28. So I want to run from 0. Now guys, remember this constraint right here tells me that my x's have to be greater than 0. So I know I need 0 up to something, and I'm just going to go up a little bit bigger than the biggest at 33. I know my y's have to be 0 or higher, so I'm just going to run up to 22. Now why 22? Well, I want something a little bit bigger than the biggest, and I wanted something a little bit bigger than the biggest on the x's. Now when I hit graph, it's going to be kind of cool because we're going to quickly get our feasible region. And it's really easy to see the part of intersection comes from here over to that point of intersection and then drops down to this point right here. So what I can now see from my calculator is that my feasible region kind of looks like that. And the solution of my problem has to be either that one, that one, that one, or that one. And you can inject an ounce of common sense and say, well, Darbro can't be that one. That point is 0, 0. And that can't be my maximum profit when I produce nothing. Now, what I can do now is I can go through and fill in the ones that I know. Well, guys, I know that's 0, 0. And from this information right here, on these x's and y intercepts, I had a guy one time tell me, he said, man, Dr. Darbro, these problems just take too long. Well, sometimes things in life take long. You know, what can I tell you? I don't know. But let's think this through, okay? When I look at my graph here, I have two y-intercepts, that number and that number. Well, I know that number up here has to be the biggest of 21, and I know that number right there has to be the smallest one because it's below it. So I know that point right there has to come from the 16 because it's the smallest number of the two y-intercepts. I know this one has to be 16. I know this one has to be 21. But it's this one that makes up the feasible region. So guys, I know that this point right here has to be 0, 16. Now I come out and I look at my x-intercept. Now, if I think about this thing coming on out here like this, and it doesn't quite go, but there's another x-intercept out there, isn't there? But I'm not worried about it. But I know of my two x-intercepts, I've got a 32 and a 28. I know that 32 has to be that one. I know the 28 has to be that one. To give you a better view of it, look on our graphing calculator. I have a smaller x-intercept and a bigger x-intercept. This one has to be 32. This one back here has to be 28. So I know that this point has to be 28, 0, just from the x and y intercept. Now, the next thing I'm going to do is I need to find the intersection of these 2 points. I could use augmented matrices if I wanted to. I'm not going to. But I'm going to use the graphing calculator. So I'm going to go second function, calc. Come down to number 5. My first curve, I'm going to hit enter. My second curve, I hit enter. My guess, I'm going to hit enter. And my intersection turns out to be, what, 20, 6? 20, 6. Now, could I have done this with augmented matrices? Absolutely. If I think about these up here as equalities, these two things right here as equalities, at the end of the day, I could have also solved a 2 by 3 and put a 1 there and a 2 there and a 32 there and a 3 and a 4. I got an email from somebody the other day said, Darbro, these matrices are actually pretty cool. It's kind of interesting that I actually understand something in a math class. Matrices are cool. They can also drive you insane. But so anyway, go second function quit, go matrix, just as we've done before. Go find that RREF business. Go back and get the matrix you want to do that of. And you'll see you get 26, which is the same thing. If you feel more comfortable doing that up here, thinking of these as just equal signs, which is really all we're doing when we're trying to find the point of intersection, then that works just fine. All right, so guys, however you do it, we've got our points of intersection here. So what we know we want to do is we want to find the maximum value of z for 50 times x plus 80 times y. Well, I find it easiest here to create just a diagram of your points. So again, our x plus 80y, okay? And our points are what, 0, 16, 26, and 28, 0. Our maximum value has to occur at one of those points. So I'm going to put this in. So I have 50 times 0 plus 80 times 16. $12.80 That could be it. I don't know yet. 50 times 20 plus 80 times 6. $1480. And 50 times 28 plus 80 times 0. So we get 1,400. So guys, the winner, the maximum profit, is going to be at the point 26. So this interpretation, we would have 20 standard tenths, six expedition, and our profit is $1,480 per day. Based on the constraints that we have provided, you cannot find a bigger value for Z based on those constraints than to create 20 standard tenths and 6 expedition tenths. Now, sometimes this whole feasible region stuff can be a little overwhelming and kind of get tedious and so on and so forth. There's another option. I want to show it to you. So keep this problem right here. Keep all this. This is called our linear programming problem. And I'm going to show you an alternative way to solve that. Okay. Now, if you go to just open up a browser, you know, whatever does it for you, and if you'll type in linear programming calculator, and let's just hit search, and I'm actually using Google Chrome, or well, Google. So if you'll come to simplex method, WEG Media, or whatever that is, it's kind of a really cool site in that it's for finite mathematics utility. And there's some cool stuff here that you know, I'll talk to you about. Well, actually, I'll show you some of this stuff. But most of the stuff here, I actually create a cooler way to do it than this. So, this is a really cool way to do linear programming problems. Now, if you'll come down here, it says type your linear programming problem below, but I think it's easier to see an example and take the example and come in and modify it. So the x value that I want for this problem is 50. And I don't have a y, or a w, I'm sorry, so I'm going to get rid of that. And the y is 80. So they call it p, and that's cool. But they want maximized p, so you can see that corresponds with our constraint. Or I'm sorry, our objective function. Now we're going to get into the constraints, so I'm going to need a 2 right there. And I need to get rid of this stuff. So I have in my first one, x plus 2y is less than or equal to 32. The next one, I have 3x plus 4y is less than or equal to 84. So they've got a little bit different here. So I've got to come in and change that out and put a less than. And I've got to come in and change out that z and y because we don't use that. Next thing, get rid of that constraint because it doesn't apply. Now it tells you down here that number 6, it says no need to enter the default constraints. The default constraints are where x and y both have to be greater than or equal to 0. So for this particular program, you don't have to enter that x comma y greater than or equal to 0. Okay? Now, It'll ask you how you want your mode, and let's just say a decimal. That's cool. Rounding to 6 significant digits, whatever. So let's just hit solve. And what you'll actually find here is it gives you, now down here it gives you some something called a simplex method. I don't study that. We don't study that in Math 1700. We use more of a graphing approach. But your optimal solution is 1480. I hope that's what we get. Yeah, it is, okay. And that'd be crazy if I got something wrong or different. And when x is equal to 20 and y is equal to 6. So guys, if you want to use this approach on your assignments at you know, at home when you're programming, when you're working the stuff on MyMathLab, you know, I'm okay with that. I really am. So if you'll just you can see the site right here. So all you'd have to do is type that in very carefully, and you get this. Okay. All right. So I'm going to leave this up because the next problem I'm going to work I'm going to work with that site just to show you that that is reasonable to do that. There's also times we have to use the graphing approach too, so that's why I've taught it as well. Let me get this all straightened up here. All right, gang, this is just a little bit harder. Not much. It's still just about organizing your work and you know, just staying true to the things that I've tried to teach you. So this is an easier problem in a way, though, because there's not as much going on. So it says an investor has $60,000 to invest in bonds of AA and B qualities. The AAA bonds yield an average of 6%, and the B bonds yield 10%. Now, it might be if you're an investor, or you know, if you're an investor, you know the answer to this. But if you're not an investor yet, you might be, well, why don't you put it all in B because it makes more money? Well, what happens is typically the more interest you get, I should say the interest you can get, the more potential for loss. So the more risk that the bond has. So the investor requires that at least 3 times as much money be invested in the AAA bonds as the B bonds. So guys, that's what makes it hard, is that requirement right there. But we'll work through it together and you'll see it's not too bad. So how much should be inversed? That's funny. Guys, I promise you I can spell. I can't see, but I can spell. So how much should be invested in each type of bond to maximize the return? All right? And then what is the maximum return? Well, the first thing, again, we want to do is we want to set up the objective function. And our return is we get 6% on the amount we put in the A's. So guys, up here, I'm going to put that up at the top. What am I going to let my variables be? So X is going to be the amount in AA's. And Y is going to be the amount in B's. So both of these are in dollars, okay? So if I have X dollars in A, I know I can take X times 0.06 and get my return. And if I have Y dollars in bond B, I can take 0.10 times Y and get my return on it. Well, the total return is obviously the sum of those, and I want to be able to get the most money subject to certain constraints. All right, so subject to, first of all, I've got 60,000. Typically, we say that, well, we're going to invest it all. Well, you don't know that. It might work out to a situation where it doesn't work out where you want to invest it all, but we know that the amount that we have in the 2 can't be any bigger than 60,000. Can't be. Now, the next thing we get into is this sentence right here. And this sentence right here drives my students crazy every single semester. So the investor requires that at least 3 times must be invested in AAA bonds as B bonds. So this is where you got to play around with things a little bit. Be patient, work a little harder. What does it mean 3 times? Well, if I have AAAs, well, that should be AAA up here. I just see them. But if I have AAAs at 30,000, and I have B at 10,000, do I have at least 3 times as much in A as I do in B? Yeah, I do, don't I? And so many times people will want to make it like 3x times y. But when you do that, to make these things equal, you have to multiply the smaller amount. So what we want is we want this value up here and this value down here. We want to be sure that when we multiply 3 times the smaller amount, that it never gets more than the biggest amount that we have in our AAA bonds. So again, is that what it says? The investor requires that at least 3 times as much is invested in the AAA as in the B. So sometimes, I've taught students this a lot, sometimes you just got to sit down and play around with this and put some real numbers in there and say, well, I could have 40,000 up here, right? But I've got to have at least 3. I couldn't have 20,000 because that's only double. I want to make sure that I have at least 3 times as much up here. Would 40,000 work? Yeah. Because that's at least 3 times. Would 50,000 work? Yeah. Because 50,000 plus 10,000 still stays within 60,000. But I couldn't have 60,000 up there because 60,000 plus. But anyway, I know that this amount, if I multiply the lower amount by 3, it can't be bigger than what I've got in there. So guys, be careful of this. Sometimes you want to multiply the lower amount, you want to multiply the higher amount by 3, and that just completely messes up the equality and the inequality. So guys, the other constraint that I have is 3y less than or equal to x. And guys, I know that both of these greater than or equal to 0. All right. I'll tell you what I'm going to do. I'm going to play a game here. I'm going to mess around. Stop linear programming. There is a famous line in a pretty famous movie. It says, "Yeehaw, Jester's dead." The first 5 1,700 students that send me an email to ddarbro@shawnee.edu, and the reason, I want you to put 1,700 quiz, and then in the body, tell me the name of the movie that one of the famous lines is, "Yeehaw, Jester's dead." Trust me, guys, you can Google it. It's going to come up in like a 20th of a second. So only the first 5 people, first five 1,700 students will get a 20-point extra credit to their homework assignment score. Now, I'm going to do this probably, I don't know, I'm not going to say every week, but it's probably going to do it 5 or 6 more times throughout the end of the semester. So those of you that are watching the videos on time and getting after it, you got the potential probably to gain an extra 100, 120 points Now, which is actually kind of cool. It actually would make a difference. All right, guys, back to linear programming. Not that yeehaw, Jester's dead isn't fun, but back to the linear programming problem. So let's work it. Now, this is a situation here when you've got something like this. So we know that, I'm just going to abbreviate here, subject to. So I know that my first one is x plus y less than or equal to 600, or I'm sorry, 60,000. Lost my mind there. And then this one, I'm going to have negative x plus 3y less than or equal to 0. Now, the first thing I want to do is I want to come in just like I did before. And I will put my x-intercepts and y-intercepts. All right, so on the first one, cover up the y. X is 60,000. On the second one, cover up the y. X is 0. For the y-intercept, on the first one, cover up the x. For the second one, cover up the x. Y is 0. So guys, what I need to do is I need to look at about 60,000 to 60,000 and check out some stuff. All right. Now what I want to do is I want to solve for these things. So first one, I'm going to have y less than or equal to negative x plus 60,000. And then for this one, I'm going to have 3y less than or equal to x, divide through by 3, and I get 1/3 x. So guys, let's grab our calculator and make some magic happen. So the first one, I have negative x plus 60,000. Guys, make sure you don't have any junk left at the end. And on this one, I want 1 divided by 3 times x, and then delete everything else. Both of these inequalities are less than or equal to, so that's kind of why I paid attention to that. So I can make it happen. Come in and reset the window. I want to go just a little bit above 60,000. And a little bit above 60,000. Hit graph, and let's see what happens. All right, gang, so we got an interesting feasible region here. Extremely interesting feasible region. Let's take a look at it. All right, so my feasible region here is clearly going to be this little triangle right down here, right? So the feasible region is going to look like that. This point's pretty easy to figure out. It's 0, 0. This point right here is really easy to figure out because that's 60,000. Well, guys, I don't want to put the... This point right here is going to be easy to figure out either using matrices or the function on our calculator. I'm going to do the function on the calculator because it's simpler. Second, calc, number 5, enter, enter, enter. So the intersection is 45,000 and 15,000. Does it hold true to having 3 times more in the AAAs? Yeah, it's dead on, so it's definitely at least. Does this one? Well, 3 times 0, you know, that's clearly by default. Of course, this is kind of dumb, you know, investing nothing, you don't really worry about much. So, as you can probably see what's going to happen here, we'll put in our points. And, well, gang, what was it? Okay. All right, so let's do it. So we've got 0.06 times 45,000 plus 0.10 times 15,000. So 0.06 times 45,000 plus 0.10 times 15,000. So your interest on that would be $4,200. Now if we go the other way, and that's kind of why I like to do this, I can go second function entry and go in and change what I need. So I need 60,000, so it's putting all of it in there. But then in this, we don't want to put anything. So in that situation, you'd earn 3,600. So gang, the winner is, based on these conditions, based on these constraints, you want to invest $45,000 in AAA bonds. You want to invest $15,000 in B bonds. And based on these constraints, the maximum return on your investment will be $4,200. Now, this kind of stuff just doesn't do it for you. That's okay. Oh well, it's not okay. You're gonna have to actually learn some of that. But let's go back to the original linear programming problem right here. Again, a linear programming problem consists of two things. What do we call this thing? This is just a classic test question, boys and girls. This is called your objective function, and this is called your constraints. So a linear programming problem consists of two things, your objective function and your constraints. So we can go back over to the website, and we can see that we're maximizing 0.06. And I really don't care as much that you use this, because the hard part of linear programming is getting the problem set up, obviously. So we're going to have x plus y less than or equal to 60,000. And then we're going to have, so 3y less than or equal to, you know, I don't know if this is going to work. It may get in a situation where we have to put that, I don't know. Let's see if it does. It may, yeah, actually it does. Okay. Well, no, it doesn't. That gives us, that doesn't give us the right answer, does it? Let's try this. Let's say we put minus x plus 3y less than or equal to 0. Because I think it has to be, let's see if this does it. Yeah, there we go. So what has to happen is this has to be, remember when we did augmented matrices, how your x's and your y's have to be lined on one side in columns and your constants. So it looks like to me that this has to be in the same form. Well, it certainly does because it's, well, you would know this though. It's using the simplex method. So, so guys, just keep in mind that your x's and y's have to be on one side. So anyway, optimal solution is 4,200, as we knew, and those amounts are 4,500 and 1,500. Looking forward to seeing who the first 5 students are going to be. That's exciting. Find out who's actually doing it the right way and who's wishing on a star. All right, gang. I think that's just about really all I'm going to do on linear programming. We're going to have some more problems we're going to work, but those will be in your study guide. So what we'll do, you know, we're within, by the time this is posted, it's going to be right at a week for your midterm. So what we'll do from here on out is we'll start focusing on preparing for the midterm. All right? So guys, have a great one.